hours, we would have sailed past the moon. After 1.5 days, we'd be at Mars. And after 3 weeks, we'd have overtaken Voyager 2 and left the solar system altogether. By this point, our ship would be traveling at 40 million miles per hour, or about 6% the speed of light. As we leave the solar system, we head out towards our nearest star system, Alpha Centauri, and see it gradually increase in brightness as we approach, whilst the sun receding into just another speck of light behind us. The next year is fairly uneventful. Each day, your ship travels about 2 million miles per hour faster than it did the day before. It's now impossible to have a live conversation with your friends currently back on Earth. The time it takes for radio waves to travel back and forth is now many months. The time it takes for radio waves to travel back and forth is now many months. After 15 months into your journey, your crew celebrates crossing the first light year. You're now just over 1/4 the distance to Alpha Centauri, but over 1/3 of the way in terms of outbound journey time, and that's thanks to the ship's constant acceleration. That's because you are now traveling away from the Earth at 87% the cosmic speed limit, the speed of light. Now, if there were no such limit, then you should expect to cross the speed of light in 45 days time. Nothing can move faster than the speed of light. Nothing. If the speed of light is a constant to all observers, then the mind-bending consequences that space and time are not constant. They shift to accommodate this rule. And that's exactly what happens here with our ship. Time shifts such that observers back on Earth seem to see the crew moving slower than usual on board. And even space shifts such that the ship itself appears squashed in length. And both of those effects scale with this famous Lorentz factor, which at this point in our journey is a factor of 2. This even affects your perceived acceleration. From Earth's perspective, you are now no longer accelerating at 1g, but rather your acceleration appears to be getting ever smaller as you approach the speed of light. Despite the fact on board, you still feel a 1g acceleration. On board the ship, of course, you and your crew would not think anything had changed. Time appears to be running just like usual. But you would notice some strange things outside the ship. Looking back at the sun, you'd notice that it would have appeared to have faded into darkness, much faster than you'd expect from a simple distance scale. By the time your Lorentz factor is 2, it's now 10,000 times dimmer, only detectable with the ship's onboard telescope, as a result of relativistic aberration and time dilation effects. Not only this, but light from the sun now appears increasingly red-shifted due to the relativistic Doppler shift. So red in fact that it now emits mostly in the infrared band, where your eyes can't even see it. But ahead of you, the opposite has happened. Alpha Centauri now appears 10,000 times brighter than it would if you were not moving. Yet, most of its radiation is now arriving as high point where we want to slow down, step off the ship, and reconnect to the rest of the universe. So one way of doing this is to accelerate your ship up to about the halfway mark in your journey and flip the ship over on its head and accelerate in the opposite direction, thus bringing you to a stop at some distant destination. The beam of light emitted from Earth would take 4.4 years to reach Alpha Centauri. Yet, because of the time dilation effects on board, you would land your ship on one of the Alpha Centauri planets, having aged just 3.5 years. Don't worry, you didn't outrun a beam of light here, because according to clocks back on Earth, the journey took you 6 years. Maybe you spend a few weeks exploring this new planet, then head back on board and make the return journey home. When you get back home, about 7 years would have passed for you, but 12 years for everybody back on Earth. Not a bad timescale to complete a journey to the nearest star, A journey to the nearest star. A journey to the nearest star. Journey to the nearest star. Journey to the nearest star.